Hello, today we're going to look at the indeterminate form of a limit. So we're going to look at a few limits, but they're going to have these indeterminate forms, and we're going to have a look at how to evaluate them. Okay, so our first question is evaluate the following limits, and our first limit is the limit as x approaches 0 of the square root of 1 plus x minus the square root of 1 minus x all over x. Okay, so let's have a look at this. So if we just plug in x equals 0, we're going to get 0 over 0. So this is an indeterminate form. So we can't evaluate the limit just by plugging the value of x in or 0 in for the value of x. So we need to do something else. So when we have this particular form, or there's a few other forms, infinity over infinity, 0 times infinity, and so forth, we can use a technique. And in this case, the technique we use is Lopital's rule. So let me see. Lopital's rule. So Lopital's rule tells us that if we have this situation, one of these many situations, what we do is the limit of our given function is now equal to the limit, in this case, as x approaches whatever value, 0 in our case, we can now take the derivative of the numerator and divide it by the derivative of the denominator. And now we can have a look at the limit. Okay, so let's do that. So we're going to write in our limit as x approaches 0. Okay, so that is one way of doing it. We could do it that way. However, there's another way that may be possible. So we can actually rationalize. Why don't we give that a try first before applying Lopital's rule? So let me just create a bit more space. So actually, let's use Lopital's rule and see how easy that is. All right, so let's take the derivative of the numerator. So that's a half of 1 plus x raised to the negative half minus a half times 1 minus x raised to the negative half multiplied by negative 1 over 1. Okay, so let's see what happens here. Limit. Sometimes using Lopital's rule is not the best way, but sometimes it is. Sometimes other techniques can be used. All right. So our two negatives, our minus 1 and our minus sign gives us a positive. Let's see. This might work, actually. This might be fine. Okay, so now when we take, let's put some brackets around this. So now when we take the limit as x approaches 0, what do we get? We get 1 over 2 times 1 plus 1 over 2 times 1. And this equals a half plus a half, or 1. So Lopital's rule works. However, in this particular case, it looks like we can also rationalize the numerator. So why don't we try that? We have space. So this would be, let's call this number 1. This is technique 1 in this particular situation. Now let's do it again. Below, let's choose another color. Let's use blue, say. And we're going to do the limit again. So this is the second possible way of evaluating this limit. So limit as x approaches 0 of, I think it was square root of 1 plus x minus the square root of 1 minus x all over x. So again, we know that we have this indeterminate form, 0 over 0. But in this case, we have this numerator with square roots in it. So we have, or I think we've seen this technique where you can rationalize to try and get rid of these square roots. So we're going to multiply by the conjugate of the numerator in this case. So we're going to multiply by the number 1, where the number 1, or the value 1, is written as the square root of 1 plus x plus the square root of 1 minus x over the square root of 1 plus x plus the square root of 1 minus x. So now you notice in the numerator, we actually have a difference of squares. So I'm going to write in our limit as x approaches 0. Our difference of squares gives, when we multiply it out or FOIL it, we get 1 plus x minus 1 minus x. And our denominator is this x times the square root of 1 plus x plus this the square root of 1 minus x. Okay. We can simplify our numerator. And if you notice in our numerator, what do we get? We actually get 2x. The ones cancel out. All right. We have a factor of x in the numerator and denominator that are common, so we can cancel those out. And we have limit as x approaches 0 of 2 over 1 plus x, the square root of 1 plus x plus the square root of 1 minus x. Now we can take the limit as x approaches 0. When we plug 0 in, what do we get? We get 2 over square root of 1 plus the square root of 1, which is this, a 2 over 2 or 1. So we got the same answer. So in this case, we can solve this limit in 2 different ways, using L'Hopital's rule or this means of rationalizing the numerator. Okay. So let's have a look at this next one. So this one looks a bit interesting. It's a little different. So now we have the limit as x approaches 1 from the positive side, what the plus sign means, of 1 over ln x minus 1 over 1 minus x. So in this case, we have this indeterminate form, infinity minus infinity. Okay, so let's see what we can do. So I might suggest putting everything over a common denominator. So again, limit as x approaches 1 from the positive side. We need to cross multiply. Right, so we end up with 1 minus x minus ln x all over ln x times 1 minus x. Okay, so now again, when we look at the limit, let's see, we get 0 over 0 this time. So now let's see if we can use L'Hopital's rule. So we're going to apply L'Hopital's rule. So this means we can take the derivative of the numerator, which is negative 1 minus 1 over x, divided by the derivative of the denominator, so 1 minus x times 1 minus x, plus, okay, ln x times negative 1. Okay. All right, so now let's see what we can do here. Let's try and simplify this, make it a little neater. Limit as x approaches 1 from the positive side. What's the best way to do this? X minus 1, we'll just put everything over a common denominator. It might be easier. There, how's that? Good. So now we notice we can cancel out these x's. Excellent. And then we have limit as x approaches 1 from the positive side of negative x minus 1 over 1 minus x ln x. All right. Okay, is this helping us? Yeah, I think we're getting somewhere. Well, let's see. What do we? So I guess so in the numerator. Now let's take the limit. So as x approaches 1, our numerator becomes negative 2. In the denominator, we still end up with 0. So we don't have an indeterminate form now, but we do end up with infinity. So it does look like perhaps as x approaches, it definitely looks like as x approaches 1 from the positive side, we end up with an asymptote. So our limit is infinity in this case. Good. So we've looked at 2 different types of indeterminate forms of a limit, and in one case we apply the L'Hopital rule, and the other case we rationalized the numerator. So that brings us to the end of our session. If you have any questions, please send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching. See you soon.